My name is Jonathan Magan, and this is going to be Project 2, which is a follow-up to Project number 1. My partner is going to be doing part 2 of this project, and I'm going to be covering parts 1 and 3. So for part 1, we are asked to do 5 different geometries in the center of the wind tunnel that we created in the last project. I already covered how to do this wind tunnel in my last video, but I'm, again, just going to cover it very briefly. So here, the basic technique into creating this dimension or this structure is to go first. You start off with your you go left to right. First, you're going to start with your settling chamber, create a massive rectangle, then go to dimensions, click general, and then you can click and drag outwards to get the dimensions of the rectangle, and basically just put those dimensions into here when they pop up, so you have the proper dimensions. And again, these dimensions are given to us in the project project pre-report. In order to create the nozzle area, you're just going to, on paper, you can actually calculate the hypotenuse of this little right triangle right here that you can create. And the hypotenuse in this case is 25.298 inches. And again, that can be reflected about the x-axis, and you can do the same thing there. For our test section dimensions, we have a height of 6 inches and a length of 12 inches, which can all be drawn with either the rectangle tool or the line tool. In order, again, to get the dimensions, you can just click the Dimensions tab and then click and drag off to alter your dimensions. In order to get our diffuser dimensions, you do the exact same method as with the nozzle, but you just do it on the other side. So in this case, our hypotenuse is going to be 42.058 inches, again, reflected over the x-axis. We then get a diffuser height of 10.402 inches. In order to create this tiny geometry in here, I'm just going to show you the half semicircle. To do this one specifically, you just click the circle. You draw a big circle, and then you draw a tinier circle inside. To get the specific dimensions you want, you can just click diameter, and you can click and drag and get the diameter of that circle. To close off your circle, you're just going to do 2 tiny lines across here, and you're then going to go to modify and trim. And once you trim, you're going to just trim this right side of the circle, and you'll be left with this. In order to make our dimensions proper, we need to do a 10% of the height of the test section, or a diameter of 10% of the height of the test section. So that'll be a big diameter of 0.6 inches and a thickness of, I believe it is 0.1. You just basically take 0.6 and divide it by 10, which would be 0.06, I believe. Quick maths. And then this would essentially be your thickness that is required. So once this is complete, you can go to create surface from sketches, or concept surface from sketch. And then you can essentially just do a box select tool and select everything, and then it will create this nice surface for you. Once this is complete, we can then move towards our next portion, which is the meshing. So for the meshing, you're going to initially right-click and click Insert Method. And when the method pops up, you can go down here and either choose Triangle Method, or you can choose Quadrilateral Dominant. I, in this case, chose triangles. And once that pops up, you can go back to your mesh, and then you can change your element size, which I did as 0.003. Once that is complete, you can either choose to do refinement, which you right-click, do insert and refinement, or you can just go to your name selections. And to do that, you're going to click this little tool here. You're going to click an edge and basically just select it and name it. So here we have the inlet, the wall, the outlet, and then when we zoom in on here, we have the front, the back, the bottom, and the top. And it's important to name each of these individual components so we can find the forces associated with each of the parts of this shape. Once this is complete, we're going to move on to our setup, which is right here. I have already gone and calculated the solution already because for some reason it was being a little bit buggy earlier. You want to make sure you use the viscous K epsilon model. And then you're going to go at the boundary conditions. You want to make sure that your inlet is the proper inlet velocity to create a test section velocity that equates to the 50 hertz from the fan, which in this case is 3.2378 meters per second. Moving on, you go to your reference values, make sure you're calculating from your inlet right here. And when you click that, it should change your velocity there. You want to make sure you do hybrid initialization and then run your calculation. This one converged in about 60 some iterations, which is pretty fast, so we can't complain. And that's the benefit of getting a good mesh. In order to see our forces, we're going to go to the, where are we at here? Not the plots. We're going to go to reports. We're going to go to forces. And we're going to just select the 4 parts of the semicircle. And we're going to click print. And that is going to print all of our forces here. So we're going to minimize these components. We're going to move this up into here. And as you can see here, this entire area here, this bottom part is the forces that are found, the drag forces and drag coefficients that are found on the semicircle. And basically, so you have your pressure force, you have your skin friction force, and then your pressure coefficient and viscous coefficient. And the totals, so this will be your total drag coefficient, and this will be your total drag force. And again, it's important to note that this is in the x direction, direction vector. So once you have this completed, you can then move on to the contouring portion of this, which can be done in the results section, making sure that this is only done after you complete the calculation, because this will not work if you don't have that done. So in order to get these contours, first I'm going to show you what I have so far. So this is our static pressure contour. Just zoom in a little bit on here so you can get a better idea. You can see our static pressure builds up at the front, so that's where we're going to have a maximum static pressure, and we have a large wake region in the back due to the adverse pressure gradient that we're experiencing. Next, we have our turbulent kinetic energy contour. Going into here, we have, this is where obviously most of the kinetic energy is going to be happening, because this is where most of our turbulence is going to be occurring in the wake region. Next, we have our velocity contour. We have a maximum velocity of about almost 16, and our velocity is going to maximize as it comes around these edges over here. And as you can see, we do have some turbulence, which is why we have that that kinetic energy contour, just so we can see the turbulence visually. We're going to have 0 velocity up along the front of the plate and along the edges of the plate due to the no slip condition. And that will complete that. And then the last portion of this is the streamlines, which is basically just showing you how the air is actually flowing over this object. So you can see we have this big wake region over here because there's no actual streamlines there. It's kind of just going all around the edges here, which is exactly what we're looking for. Now, in order to get these contours, all you have to do is go to this button here, click contour. You can do the name of your contour, and then there's going to be a little screen that pops up here that allows you to, I'll open it up really quick. It allows you to choose kind of your parameters for your specific contour. So you want to make sure that symmetry 2 is chosen. For this one, it's just pressure, and the higher number of contours, the higher, the more accurate your contour is going to look. So I did 200 contours. So I'll just apply that again just to show you, make it appear. And again, that's what it looks like. So this is going to conclude part 1 of project 2. I will follow up with a project 3 video covering the airfoils momentarily. Thank you for watching.